Today we will be proving the Apollonius theorem. Apollonius theorem. So suppose ABC is a triangle, ABC is a triangle, and we will draw a median. Let's say this is a median D, and we also have to draw a perpendicular line that is this angle 90 degree. So we need to prove in Apollonius theorem that AB squared AB squared plus AC square is equal to 2AD square plus 1 by 2 BC square. So this we need to prove. Okay. So let's start the proof. So first we have to let's this perpendicular is meeting at the point E. Let's say this is E. Okay. Now we will be using the Pythagoras theorem throughout it. We know that AE square plus ED square is equal to AD square. From here we can find the value of AE square is equal to AD square minus ED square. Okay. Now let's see the triangle AEC. So now we will check the triangle AEC. So here we know that AE square plus EC square is equal to AC square. Okay. Put the value of A square which we have calculated along before. That is AD square minus ED square. As I already told that D is the median, so BD equal to DC. Okay, we can write that. We know that actually we know that. So we can write EC square as ED plus DC whole square. Actually, I'm gonna do it uh, quickly. So I'm just driving in and writing the exact thing. Okay, and if we whole square it, you all know the whole square formula. We will get ED square plus DC square plus 2 ED into DC. Now you all know that DC square, we can write DC square as what? Half of BC square, because we all know that D is the median. So you all know that DC square is equal to half. I mean DC is half of BC. We can write that. So let me do the changes here. Okay, I'm just doing the changes and again showing you the result. I'm just removing the DCs because you all know what it result. So half of BC square, if we do the whole square in place of this, it will become 1 by 4 BC square and 2 ED into 1 by 2 BC. Okay, this is very easy to understand, and we will just cancel this 2 and this ED and plus minus always get cancelled. So we'll get some a face of the equation as this. Okay, I will get one of the faces as this. So we're getting one of the face like this. So this will be our first thing to remember. when we are solving in triangle AEC. Now we will do a similar thing but in the triangle AEB. So let us do it. Now they are doing it in the triangle what AEB. Okay, remember now we are doing in the triangle AEB. Now the thing will be a bit different but more or less same. AEB triangle. So as you all know that AE square we know plus BE square is equal to AE square plus BE square is equal to AB square. We all know that obviously. Not in rocket science, we all know that. Now what is actually B square? Again B square is, if you see it, if you see at the sum you will understand that B square is, we can write first we are putting the value of A square. What was that again? Let me see. AD square minus AD square, AD square minus ED square, and B square, if you see the figure we can understand that it is nothing but BD minus ED. So let's write here BD minus ED whole square is equal to AB square. Okay, not writing it. I will write at the last. Okay. So again we can just whole square, and again I am not doing you. I am doing it directly because you all know that. Just listen to me here. That BD is equal to half of BC because DAD is the median, and so half of BC square will be 1/4 BC square. We all know. So I'm just doing it directly. 1/4 BC square. The whole square formula you all know that. All know, right? Plus ED square minus BD, sorry, BD into ED. This is one of the equation that we got. Again we can cancel it, and this is one of the thing. This is AB equal to AB. Okay, AB. So I guess you have understood the sum right now. So now we are in the end game. That is the end part of the sum. Where we need to actually prove this theorem that I give you. So again I'm just reminding you why we are here. Again I am reminding you why we are here. We need to prove the theorem that AB squared plus AC squared is equal to half of AD square plus uh, sorry 2 AD square plus half of BC square. We need to prove this thing, right? We all are just reminding you. So just reminder to this one. So what we have right now, let's check, guys. We know the value of AD square. We know the value of AC square that we found here, and we all know the value of this AB square, right? This AB square value and this AC square value, we all know that. So now what we will do, we will simply add them because we need to get we obviously need to get AB square plus AC square, so we just add them. So we can write here a adding this to AB square plus AC square. We are adding them, and by adding that we are getting what, this AD and this AD will get add, so we are getting 2 AD square. Then the fun part will be that this ED into BC and this ED into BC, if we are adding, will get cancelled, and we will getting 1/4 BC square plus 1/4 BC square. 1/4 BC square plus 1/4 BC square, which if you do the fraction, obviously will uh, get 1/2 BC square. It is 2/4 BC square, 2 4. Okay, you all know that 1/2 BC square. So we actually proved this. We actually proved this, guys. We actually proved this thing, and it was very much easy. To AB square plus AC square is equal to 2AD square plus half BC square. So how we have proven this one? Let me show you. We have first proven the triangle. This was a triangle. I'm just doing a rough thing to again make you understand. this is our 90 degree, and this is our median, that is D, and this is our A, and this is our what was this, C, and this is our B. Just make me understand again. First we had to find the value of AE. We found the value of AE. Then in triangle AEC we did some fun and calculate the value of AC. Then in triangle AEB we did some fun and calculate the value of AB. Then we added them to get our result, that is the Apollonius theorem. So guys, this was only the Apollonius theorem. If you like the video till here, thank you. Consider subscribing.